I'm curious to know why these massive data centers are being built.
In fact, these large data centers are probably far less useful than they seem. Data processing only makes sense if the data is of high quality. Otherwise, the garbage in, garbage out rule applies.
Basically, all the info you can find online is already included in the models. Richard Sutton also wrote another rule about this in his essay, The Bitter Lesson. LLM gets better with scaling. So, according to Moore's law, which says that computer capacity doubles every 2 years, this is the solution. The more data you have, the better. The slogan is, scale is all you need.
The biggest lesson that can be read from 70 years of AI research is that general methods that leverage computation are ultimately the most effective, and by a large margin. The ultimate reason for this is Moore's law, or rather its generalization of continued exponentially falling cost per unit of computation.
But Richard Sutton now believes that there is a limit to this. Perhaps I should first explain what that limit is. Almost all the naturally available data on the internet has already been taken and is used by LLMs as training data. So it looks like the only option here is to generate synthetic data.
So what actually is synthetic data?
It is data that an LLM generates itself. It takes existing data and uses it to make new documents based on probability. But the quality is no longer the same.
Why is that?
The quality decreases with each generation. In 2023, mathematicians recognized this problem and addressed it. Several studies on this topic have been published.
In that case, LLMs should not produce synthetic data. They can also use the data that is constantly being produced by humans.
As long as humans are still the ones creating this data.
Who else would it be, right?
More and more people are using LLM to write their texts. Then it's synthetic data.
But how many people actually use large language models for their writing?
Meanwhile, an increasing number of companies are now having their texts written by LLM. Here's why. More and more people are using chatbots to find out about brands. It is therefore very important for companies to be portrayed in a positive light by chatbots. To achieve this, companies are turning to the sources used by chatbots. These are websites. Companies are therefore creating new websites that are just there to be included in a chatbot's dataset. And the most cost-effective way to do this is to produce the content for these websites by chatbots. In addition, they can prompt a chatbot to create web pages that are more suitable as references for them. This generates texts, which are synthetic data. Then the brands can test the image with the chatbots again. If they are not satisfied, they instruct the chatbots to create new web pages, which in return are copied to generate their responses. This creates a spiral where the AI is constantly copying itself.
But is it really so bad if chatbots use synthetic data?
Yes, because this causes the chatbot's responses to become increasingly poor. More and more details are lost. Perhaps this can best be understood by looking at art history. In the history of art, there have been always styles that were copied. But then the style became a bit tired until people lost interest in it. A good example of this is Impressionism. At first, it was revolutionary and provocative. It was a completely new way of painting. Then it became successful and more artists imitated the style. This marked the beginning of the decline of Impressionism, until eventually no more artists were painting in this style. Art always needs renewal, and within a style, these renewals are limited.
So creativity is about doing something new, right? But is it possible to keep the quality of the copies consistent?
The point is that details are lost with every copy. This has been known in art history for a long time. But a few years ago, mathematicians discovered this too. They looked at AI models and did experiments to show what happens when more and more generations of copies are made.
Hopefully they have figured it out.
You can see this best when you look at the copies of the images. The first images that the AI received show very different people. You then ask the AI to make a copy of these images, then another copy. If you look closely, you can see that details are lost with each copy and the people become more and more similar. After several generations, all the people are extremely similar.
Indeed, almost all people look the same now.
They did the same experiment with numbers. They started with normal, easily readable numbers. With each subsequent generations, the numbers become less clear. After 10 generations, the numbers are blurred. After 30 generations, they are basically illegible.
That's amazing. How does that work?
The problem lies in the probability calculation on which AI is based. It doesn't just copy, it calculates the probability of the words appearing in the text or of pixels being represented in an image. In the first generation of the copy, there is still a bell curve. There's a high probability that the copy will be correct and that the right word and the right pixel will be found in the right place. But in later generations, the curve narrows. Information at both extremes is lost. Ultimately, you are left with just a steep peak. The information is reduced to such an extent that there now seems to be only one correct answer. Anything that deviates from this has been eliminated.
That's not really very creative.
Creativity is subject to the power law. The curve of a power law looks very different from that of a normal distribution. It is a pattern of extreme events with a long tail. Most data is clustered together, but creativity is at the far end. Creativity is what is unlikely. It lies exactly where AI eliminates information on the curve. That is the extremes.
So AI isn't creative at all?
No, copying has never been considered creative. The philosopher Leibniz gives a definition of creativity. It is the inner ability to imagine something independently. Creativity is innovation. It is the creation of something new that didn't exist before. Because AI is not creative, it cannot produce information to train itself.
Well, even if AI cannot be creative, that still does not explain why the quality deteriorates with each copy.
That is because of the probability distribution. AI models do not produce an identical copy of the original. Rather, they base their copies on probability calculations. Anything that is improbable is eliminated. Each copy is a reduction of the original. This is not only a problem when it comes to copying images or text, it is a fundamental problem with AI. For example, a medical chatbot will no longer list all diseases that match the symptoms. When you ask historical questions, an LLM will not make a distinction between facts and interpretations. And with each generation, the results get worse.
I can't believe it.
Scientists have worked out exactly how this happens. They share their findings in the journal Nature.
We find that indiscriminate use of model-generated content in training causes irreversible defects in the resulting models, in which tails of the original content distribution disappear. We refer to this effect as modal collapse.
A collapse? Then there's not much hope.
We show that, over time, models start losing information about the true distribution, which first starts with tails disappearing, and learned behaviours converge over the generations to a point estimate with very small variance.
Could they have miscalculated?
We show that this process is inevitable, even for cases with almost ideal conditions for long-term learning. That is, no function estimation error.
Perhaps an algorithm could be written to counteract this, for example, by restricting simple copying.
Scientists have considered this option too.
We find that data generated by language models in our experiments end up containing a large number of repeating phrases. The repeating problem has been observed in nearly all text generation models, and to rule this out as the cause of modal collapse, we further provide numerical experiments when models are explicitly encouraged to produce non-repeating sequences with a repeating penalty of 2.0. We find that this causes the models to produce lower score continuations to avoid using repeats, which, as a result, causes the consequent models to perform even worse.
Okay, so that won't work either.
The only solution is to improve the quality of the data.
Our primary conclusion across all scenarios is that without enough fresh, real data in each generation of an autophagus loop, future generative models are doomed to have their quality or diversity progressively decrease.
What does autophagus mean?
It comes from Greek and means something like self-devouring. With this term, they created a funny abbreviation for their theory.
We term this condition model autophagy disorder, mad, by analogy to mad cow disease, and show that appreciable madness arises in just a few generations.
After mad cows, now we have mad AI.
But only if we carry on as before.
Some ramifications are clear. Without enough fresh, real data, future generative models are doomed to model autophagy disorder, MAD, progressively losing quality or diversity and amplifying generative artifacts. One doomsday scenario is that, if left uncontrolled, MAD could poison the entire internet's data quality and diversity.
And when is all this supposed to happen?
In the near future.
After all, our autophagus loops went appreciably mad after just 5 generations. It seems inevitable that AI autophagy's unintended consequences could arise in the near future.
But you can see this regression to the mean in the first generation of a copy. If you ask 10 people, 100 people or 1,000 people for the definition of a word, you will get similar but still quite different definitions. If you ask chatbots the same questions, they will give you almost identical definitions. This is because they all retrieve their information from the same sources. A lot of the complexity of human definitions is lost.
The limitation is built into the algorithm.
Growth always has its limits. Only imagination knows no bounds. We can imagine that models will keep improving, but the models themselves cannot. There are technical limitations. Growth is not infinite. We just have to make do with the amount of data we have.
Okay, if you have any questions, just leave a comment. I hope you enjoyed the video. Don't forget to subscribe, and we'll see you next time.